yeah, because I want to keep it as informal as possible. So, and there's some podcasts that start like this. So I'm gonna try and see if I get the good retention still. But yeah, thank you and welcome to High Point, Fabia.
Thank you for the invitation.
I've seen and I knew you. I've known your face for quite a while because you've been very active on LinkedIn, and I'm very happy to have you here because I'm organizing episodes. And I don't know if you saw you know it's from the social media. But
I do. Thank you so much.
yeah. So I have obviously a lot of questions to ask you, like any other guest. Obviously I'll ask you to introduce who you are, your background, your previous experience in other jobs. You used to work for Henning Larsen, your specialties. Obviously, I'm an acoustician, not an expert in moisture and other things you are a specialist in. So it would be really interesting to, in layman's terms, to explain some challenges. And also I know you're very active with building wood and other projects as well. And you're going to the International Mass Timber Conference. Oh, your jury, is that right?
Sorry.
You're part of the jury or
Yes,
committee?
I'm part of the organizing committee, exactly, and I
Oh,
will also be a speaker
I
on
didn't know that. Okay,
your
well
panel. Yeah,
I'm going to see you in person there.
nice.
But yeah, can I ask you to introduce yourself the way you would like to be introduced?
Of course. I mean, you said some important points about me already. I'm Fabia, originally from Switzerland, but now I'm located in Denmark, working at the Danish Technological Institute in Copenhagen at the moment. I started as a carpenter more than a decade ago in Switzerland. I would say classic village carpentry, doing a bit everything, whatever people needed.
What
And
age? What age did you start? Sorry.
what age? I think I was 20 when I started that. And so I was doing an apprenticeship for 3 years, working as a carpenter and like really learning how to work with the material and also fell in love with the material. And from there, I went to study timber engineering, which is structural engineering, focusing on the material timber. So you learn all the structural specialties, whatever you can build with timber, and but also go deeper into the materials capabilities and properties and so on. That's what especially fascinated me. I did a master's in Denmark at the DTU, Danish Technical University, and worked, as you said, for Henning Larsen Architects a couple of years before I ended up here at the Danish Technological Institute, where I'm a timber engineer now and working with all different kinds of aspects of wood and other bio-based materials. Timber is a building material, basically.
Yeah. So I presume you've got a fairly good overview of what's going on and
I
what's going
hope
to
so.
be developed, hopefully. um, but yeah, it's quite interesting. When I started, I did some 2 years in Grenoble, which you may know. It's very close to Italy. There's loads of Italian students, and obviously it's very close to Switzerland. But there's a university specialist in timber, and there's a lot of engineers who come from there. And I've always thought it was so niche. There was no jobs where it was ages ago.
The
And
opposite.
now I'm just thinking, how stupid was I? It's just booming at the moment. There's so many things to know about timber. Um,
Absolutely.
so yeah, what sort of things did you learn at uni, and what sort of topics did you to answer the young Mark who's really narrow minded about timber?
I mean, I learned, I mean, maybe not everything, but almost everything about timber. The studies are based on that you have a background as a carpenter or cabinet maker, so they don't start with explaining what wood is. They expect you to come with some background knowledge. And so we were building up on that. We were learning a lot about the structural properties of wood, how to construct buildings, taller buildings, even to high-rise bridges and so on, how to do that, how to calculate that. That was maybe not my favorite. What I loved more was going into the properties of wood. So I had like the biological, physical, and chemical aspects of wood. Why is wood reacting, how it is? What are the cells saying about the wood? Why do different species react differently, for example, when they're exposed to some external influence? So that was what really was fascinating me, and that's what definitely made me choose to continue with that. And part of the studies was also an internship. So then I went to a year to Norway to Helen Hard Architects, and that's also when I fell in love with that bridge between architecture and the engineering. So doing the translating the design basically into a feasible building and how to solve it beautifully, that it's still like structurally sound and safe and works and should look nice for a long time and last and be durable. So that's what I continued focusing on afterwards as well.
Why did you decide to go to Norway? Was it
Yes.
because it was the only opportunity, or you were really interested in the country?
I knew that I want to go to another place. I mean, it's quite a cool chance as a student to go abroad. There were not really exchange options as far as I knew, at least otherwise. So I knew like the internship would be a great opportunity to go abroad and see another country. At that time, I did not plan to live abroad for a longer time than that 1 year, but I really fell in love with Norway or Scandinavia in general at that time. So I was looking for a place in Scandinavia because timber industry, or like the timber tradition, has also been quite strong up here, at least in Norway and Sweden. So I was looking for interesting practices there, and got put in contact with Helen Hard Architects, which was a really interesting place to be, and I learned a lot for sure. And it was also very nice to get that Scandinavian experience, and that's also what made me come back to Scandinavia for my masters, even though not Norway, so Denmark, but it's still closer by, at least to Norway, and has that Scandinavian lifestyle.
So how many languages do you speak now? Obviously, you speak by default or legacy 3 languages, being living in Switzerland.
We actually do have four official languages, but no, we don't learn all of them. That's a common assumption, but we don't. So yeah, I do. My native language is German, or more precisely Swiss German, and then we had to learn French and English, and I learned Danish and Norwegian. That's the ones I would mention. Yeah.
That's pretty amazing. We speak 2.5 languages.
I mean, that's a start.
Did you do your masters as an Erasmus or an exchange, or did you do that as you just registered it at the DTU?
The full masters here, so
Full
it
masters.
it was not an exchange, and it was in architectural engineering actually, because at that point there was almost no timber studies here in Denmark yet. So even though Denmark is part of Scandinavia, the tradition of building in timber hasn't been that strong compared to Norway or Sweden, or maybe just in smaller scale. So at that point, there was not much to study about timber at the DTU, the Danish Technical University. But I chose these studies because I learned more about buildings in general, indoor climate, how to build buildings better for the users, more sustainable, and so on. So that gave me a bit more holistic approach, I would say, to buildings. And of course, I always applied it to timber buildings whenever we had projects where we could choose.
Um, so your first job was with Henning Larsen.
The first full job, yes, but I was in carpenter before, and I was in internship in Norway. So, but the first full job as an engineer was at Henning Larsen Architects.
How was it?
Very interesting. I mean, great projects, great colleagues, for sure. I learned a lot there as well. It was, it's one of the biggest Danish architectural offices, and has a big legacy. And I really met them at the correct time. They were looking into sustainable solutions and how to build more with timber and other bio-based materials. And I got in contact with them, and they started to employ me as a student still, and then kept me once I was graduated. And so I would say we really profited of each other. I mean, I could learn a lot about the Danish building industry and about working together with architects and other collaborators, while I could give my knowledge on timber further. And it's really nice to see that quite some of our ideas are being built or already completed now, finished building. So that's always nice with the building industry, having this very the result in the end that you can is very tangible. I think it must be more than 10 by now. I started, it was, Denmark is the main one, but then it was Germany and Norway, the US, Australia now, and Hong Kong. There must be more by now, so it's been growing quite a lot.
And so I've worked with other big firms like this that have an engineering team, and it was quite interesting. How big is the engineering team, if there's an engineering team, and how do you work as an engineer in those sorts of firms? Do you work early on projects? Do you work all the way through your projects? How does that work?
I mean, now I haven't been there for a while, of course, so I don't know how exactly it's going. But for one, Henning Larsen is now part of Rumble Engineering, so they have a lot of engineers there. And I was the only timber engineer at Henning Larsen, but there were quite a lot of sustainability engineers and smaller team, basically being involved from very early on in the team in the projects. And I think that's also what the building industry really can profit of having engineers very early on involved in projects, because then you can find a solution together that is really aesthetically pleasing and working well, instead of the architects going all wild with their ideas and then the engineers trying to fit it into some kind of box later on. Then it will just be compromise for both sides and not satisfying. So when you have the collaboration early on, you can guide the architects, and they still can, like, within maybe that set of guidelines, go very creative and find very nice solutions and really explore the materials in way nicer ways. And so together with engineers, a small engineering team that were covering everything from the light studies, light simulations, LCA, so life cycle analysis, calculations, and so on. We were giving input early on in projects.
Yeah, it's a pretty good idea, because how many times on projects do we struggle to be on board as engineers early enough, and we come Absolutely. And have to either fix problems or add problems more than create another solution. And there's a previous guest, which by the time we produce or publish this episode, it will have been published by Water, and they say on many buildings they try to engage some engineers first, especially the structural engineers, especially if it's a timber building, and then they will engage architects more than the other way around. So it's quite interesting. And you, we're going to talk about the connection between engineers and architects, but it's kind of covered with. Yeah, there's no other questions around this, unless you've got any comments. But it's one of my on my list of things to say. It's I guess the main thing is to have when you get on a project, especially a timber project, it's so important for all the engineers to be already in the loop. And I can say from like tons of experience, either we have to slow down some of the design when the engineers come in, especially acoustic, or we have to do another phase again of design because the project is not mature enough in design,
Exactly.
especially for acoustics. I don't know if you've got similar experience.
Yeah, I mean, there's of course a lot of constraints. I would say for the quality of a building or a project, it would be great to have some more time. Almost all projects feel rushed. It's a lot about money, of course. People want to save, and some of them are also a bit optimistic with the time plan. Don't calculate enough with real life circumstances. There's delays on a lot of different occasions, of course, usually in projects. And this can, of course, have an effect on the quality of a building in the end if everything has to be rushed. And so it would be great if people understood that it's worth having a little bit more time to, especially timber buildings, they have to be planned properly in the beginning because a lot of it is happening through prefab. So the earlier on, you'll really have like good, solid planning and integrating all the things you need to, especially in prefab, you need to integrate all the electrical installations, all the piping for water and sprinkler and of course ventilation as well. So you have to decide that very early on. And if you don't have enough time for that phase, then you will run into problems later on. And that just has a bigger effect in higher costs than what you probably could just have initially used on planning a bit better. And so it would be really great that if they understood that it really helps to add some extra planning time and allowing for the prefabricated building some more upfront time for that and involving specialists. Sometimes it's also contractually difficult to involve engineers or certain contractors or specialists early on, so that they're not allowed to engage these people early enough. So it would be quite nice if the right people could be taken on board early on. So sometimes, for example, it could be nice already reaching out to a couple of potential manufacturers of a timber system, just to hear like where could we optimize our design so that it's better in terms of cost, and maybe we can optimize something so it looks more beautiful as well, is more realistic. But quite often the contracts say you're not allowed to reach out to manufacturers early on in the design stage, so that comes just later on. And
why is that? Sorry, why is that?
What that is?
Yeah,
I
why
mean,
then you're not allowed? Why is it contractual?
it has to do with, especially with public projects, it has to follow like very strict phases, and in specific phases you are allowed to get offers from manufacturers then to continue with like those more concrete offers of different companies, and before you usually keep it open. And so you're not allowed to go early on out to the industry sometimes and get these tips from the manufacturers directly, even though I think that could help the quality of some project. Of course, if you're in private construction, then you have a bit more opportunities, but especially for bigger public projects, you have quite a lot of constraints, and some of them are based on traditional concrete industry and not that very well adjusted to the timber industry. So it could be nice to acknowledge that some systems maybe work differently, and that it could be nice to keep it more flexible, or at least adjust it to those needs as well. Because in the end, I would say our goal is to have buildings that are beautiful and last as long as possible with a high quality. And I think that's a way how we could get a bit better, at least.
Do you have some quantity surveyors in the house at Henning Larsen, or people who would be able to cost things, the design from really early on? I'm asking the question because I wonder whether we should be doing it as well. Know the impact, the cost of our design as a minimum.
I would say now a more general answer to that is that I see a lot of architectural offices don't really do that. The like calculating the costs, or just very superficially. So usually external companies get contracted for that, and it's really dependent on who you have on board. Some of them have a lot of experience. Others, especially with timber construction, if they haven't worked much with those before, you see that they're quite insecure how to price the costs for a timber building, and then they add a lot of safety factors. And so especially in architectural competitions, when you compete against other companies and they maybe suggest something in concrete and you're proposing something in timber, and then they add a lot of these safety factors on top because they just have never priced the timber building, then you're suddenly by far the most expensive, even though it might just be like barely more expensive in timber. And that's a pity, because usually the price is what makes you win or lose, apart of course of a beautiful design, but the price that's just reality, is a very important measure. So it's a pity, and I think it could definitely help if both the industry get more knowledge on like correct pricing, but for that we need of course more experience as well, but also the architects to know early on, is this a solution that like doubles the building cost, or are there ways to optimize the design to reach the targets early on?
Yeah, it's through the podcast actually that, well, maybe not completely, but that I'm thinking we need to know the cost of our design. For example, whether obviously there's loads of acoustic benefits created by concrete. I'm not an advocate for concrete, but I just try to be more objective. But what's the cost difference between pouring a concrete slab and a resin layer, or having a more dry solution? Obviously, there will be a cost in products, but what's the cost in installation? What's the duration installation? And I think maybe we should, well, obviously we won't be that competitive because we will add more services, but maybe add some costing services to it, so we can have a good idea and we can say for certain, no, look at this, because in the long run, at the end of the project, this solution will be cheaper. And the same for box-in-box systems. There's a project where I'm really interested in paving slabs, reclaimed paving slabs, and using them and bonding them. But obviously, there's a big question mark on how to procure it, where we can get it. Obviously, as a material, it's quite, if it's reclaimed, it should be fairly cheap. But what's the cost implication? Obviously, it's got good sustainable implications. Maybe one day we may provide that service.
Yeah, and I think, comparing those costs, what you mentioned, it can be very complex. So quite often people compare material prices one-to-one, but then, as you say, it can have a lot of different implications. It can reduce building times and so on, which are very difficult to put a price tag on. So it's still, I mean, I understand why there's so much insecurity about costs. I'm not blaming the people calculating these prices and adding a lot of safety factors on top, because we just don't have enough data yet. So in that sense, it would be really nice if we had better, like maybe collaboration within the industry as well to help out each other, because then we also get forward together with these newer solutions.
Okay. So what are your responsibilities at the DTI, Danish Technological Institute? What do you focus on? You got some specialties? Yeah, that's a big, wide question.
That's a very wide question, and also my jobs are very wide, different areas I'm working in. So I'm working at the our team are all working with timber and bio-based materials, but within our team, I mean, there's 30 specialists working with all different aspects within that. It can be from cladding and impregnation, durability, and testing of those. But it goes also to fungal analysis, if the timber gets too wet, and so on, analysis of that. And I'm working more with the structural parts of timber. So I'm not doing the structural calculations, but I'm still trying to give consultancy on it. It can be in choice of materials. Then we have a lab to test and also like certify building products within timber and bio-based materials. I really do enjoy that practical aspect of work as well. So it can be something like particle boards that are strength tested. So basically we break wood and look how strong it is. And if it fulfills the standards mentioned, then they can get the certificate. Or the producers can just mention how strong their products are, so that then the engineers can work with those numbers. There's also a lot of work going on within new bio-based materials that we're sometimes testing, that can be with fibers or particles from different materials than just timber. So a lot of agricultural waste products, for example, or things coming from the sea, plants and so on. And there is also a lot of work going on within the reuse of timber, which is quite complex, with the recertification to figure out what has a piece of timber gone through and how can we make sure that it will last long again if we use it, or can we use it for a different product? Should we make some kind of engineer product from it, some kind of board, a CLT board, for example, or can we use it one by one in a building again? So I'm working with those strength testing, consultancy of clients, and EU projects within that. So EU projects are one is Wood Circles, it's called, project that is focusing on the reuse of timber, and the other one is Timber House called, which is focusing on the utilization of basically underutilized forest products. So whatever is not used enough at the moment in the construction industry, because we acknowledge that, I mean, with the increased use of wood, of course, we have to find ways to maybe use more of the products from the forest and not only focus on 2 species and only use, I don't know, I'm just saying a number, 40% of a tree for a construction material. Like, how can we use more of the tree? How can we use more different species? How can we make sure to reuse timber? How can the design be influenced to be to be able to be reused basically later. So I'm working with EU projects which are super interesting. They're like spanning across a lot of partners and countries. And a last area is that I'm working a lot with moisture in timber. So going out to building sites where a client is suspecting timber has gotten too wet and taking samples, and the specialists in the lab are looking if something has been growing on the timber and if it's something dangerous, and then we find solutions how to find like remedies for that, or just in general consultancy how not to get to this point, how to not have your timber get wet.
That's a lot of topics. I want
Yeah.
to, but it's really good, and this podcast is probably going to last longer than an hour. And it's okay because it's for me to learn, for people who listen to learn. So let's dive in details. And first of all, what was the first one? Is in materials and bio-based materials. What are you working on? What are the promising materials of the future? That's a very vague question, but what are you working on?
I mean, of course, now that I'm a timber engineer, I might be slightly biased. I definitely think timber is a construction material for the future. Thinking about CO2 and the climate crisis we have, steel and concrete using or emitting a lot of CO2 when constructing. So I think timber is definitely part of a solution. We have to keep in mind maybe boundaries we have, which is, for example, how much timber we have. It's not that we are at the stage currently that we have to be afraid, because the forests in Europe, they're really plentiful and they're still increasing. They've been increasing in size, and we're not using as much timber as we could. But if we're thinking about the future, we definitely have to think about using, as I said, with one of the EU projects, different species, and use just the timber that we have better, reuse it, and so on. So I think timber is definitely the material of the future, combined with other bio-based materials. So the other bio-based materials are usually less structural, but more for cladding. It can be acoustic panels, it can be flooring or other fittings, it can be insulation materials, for example, from a lot of different plant-based fibers, instead of the classic mineral and glass wool, for example. So I think the combination of that is really something we have to look into more in the future. Also, not only the CO2, but also other effects on the planet with chemicals, for example, that are in certain other products. And a lot of these bio-based materials are either waste products. As I said, it can be something like straw or other fibers, hemp fibers, and so on, from which are basically a leftover product. So we can use that. And what is special about those is also they are renewable materials, also timber. So they regrow, which is really a difference to, for example, steel and concrete, the more conventional building materials that once they're used, I mean, they don't regrow. And with the increased need for, I mean, the planet is getting populated more. We build more buildings, and that's one way to solve it, at least a little bit, the climate crisis.
To dig even deeper, what sort of acoustic materials are you working on? Acoustic panels?
I mean, I'm not working so much on that, so I don't want to go too deep into it. And of course, we also have clients that are still in earlier stages of developing things. But what I know and what I've used before in projects have been eelgrass acoustical panels of seaweed.
No, I think I know who you mean.
Yeah, and those ones, those ones have been, I think they're quite nice. They can also be like as a visual element basically in rooms. They're not smelling of seaweed.
No, I can confirm
Yeah,
they don't.
those are really, really nice products. But there's a lot of manufacturers out there that are trying new products within acoustics, but also insulation and so on, particle boards.
How do you cope with, say, eelgrass was very successful and there was a lot of demand for it? How would you cope with the demand? And do you have to have crops?
I mean, now I'm more in the early stage of these products. Of course, I'm not there once they're successful. We're probably not used or needed anymore, as we're more in the development and certification stage of these products. But I think part of it is probably then regulated by the price. If there's just not more of this material available, I guess then the material gets more expensive and the demand gets smaller. But I'm not an economist, so I don't know so much about that. I think it would be stupid to use or like overuse, of course, our natural materials, and that's also valid for timber and other crops, for example. I think it should never be something that could be used for a better use, as for example food or so on. First, so it should always be some kind of waste products or something that could be replanted and regrows quite quickly. But a lot of these fibers, they're actually growing quite fast. So I don't think, and our oceans are so big, I think eelgrass is not harvested completely out of the ocean, everything so quickly.
And one question I always wonder is, how do you deal with the fire resistance or the flammability of those materials? Do you study them and try to improve their?
Yeah, that's a very relevant question. We don't do fire tests at the DTI here, but that's a resistant point. We often see why material cannot be used in a building. So it's very dependent on which country you're working in, what the fire codes say. So a material might be allowed in Norway, but not in Denmark, and so on and so forth. So it's not so easy. Sometimes they treat materials with some kind of salts to have a bit higher fire resistance. And then, I mean, the main way is to do fire tests, full-scale fire tests to get approval of these materials. And there might be some applications where you're not allowed to use it, but especially for more like surface panels and so on, I think there you're allowed a bit more. But once we go in, now I'm working with timber, with the structural materials. There, one option is encapsulating the timber. So usually we're talking about cladding it in gypsum boards to avoid the timber of burning. That's it always, yeah. People think it's a pity. I mean, I understand that absolutely, because a lot of people love to see the timber, but we also have to remember that the CO2 benefits and that it's a renewable material and so on, these benefits still stay, even though you cannot see the timber in the end. So I think we have to keep that in mind, that the timber building is still a good idea, even though you have to clad partially the building in gypsum. You still have all the advantages from the CO2 that you can bind in the construction, the quick installation, for example, the prefabrication, the dry construction method. And you cannot see it. Yeah, some people maybe are even happy if they have clean rooms that are just white around. So people are having different aesthetics and wishes. So I think we should have the options for both. But sometimes it is needed. Yeah.
So you you mentioned clients, and I didn't realize it's something I hadn't planned. So obviously, the DTI doesn't only do research with grants, but they also has a commercial aspect. What what do you do exactly? Do you get approached by a company saying, "Oh, I've got eelgrass that is great. Can you advise us? Is that what they do? And can you test it and tell us what the limits are?"
I mean, it can be exactly like that a company approaches us at the very early stage, being like, maybe you can make this into a product. Or it can be something like, we have this product, can you test it, how strong it is? And then we can tell them it had this strength, and maybe they want to improve the strength, for example, or change something in their mixture. And then we can retest it. We sometimes, of course, depending on what they need, we can be very flexible on advising them and improving. And of course, the clients, I mean, we keep those informations very much to ourselves. But having worked with so many different products, of course, we do have a lot of experience over the years, what might work or what might be a bit more difficult. But we've had a lot of very interesting projects going on. Of course, I would say my work personally is now maybe 50% from grants and funding from EU projects and so on, and 50% from a lot of different clients and consultancy jobs out in the industry. And our goal at DTI is basically to make the industry better. I mean, to bring out knowledge to them to help the industry as well to, for example, build better timber buildings. Of course, DTI is doing a lot of other stuff, but like in my focus area. So we can gather that knowledge here a bit as well.
So what are the services? Can you do the list of services you provide? I'm doing it. I want you to do a sales pitch here. But so moisture resistance, structural resistance, is that right? And
we do really a lot of different stuff. We don't do acoustics really. We do a lot of strength testing on materials. We do moisture testing, fungal analysis. We have surface treatments of materials, modification of materials. I really don't want to forget any of my clients, my colleagues, of what they're doing. We have so many different specialists, and it's really dependent on who is working at the DTI at the moment as well, because we all come with our very special competency. And so if I come with a very special knowledge, then I can also have basically my own clients on that. So it's also person dependent on that. But I think that was the main areas. We do furniture testing as well. So certification, strength testing and so on furniture, which is quite cool to see basically like a little weight pushing down on a chair 10,000 times or 100,000 times even to imitate somebody sitting on it and seeing if it's strong enough. But I mean, all of this basically helps the products and the industry getting better. We do also do direct consultancy, companies coming to us and asking, like, how can we build this beautiful timber structure? We have no clue. Is this even possible to do in mass timber, for example, or should we use another material? What kind of material do you suggest for the facade cladding? What happens? Maybe is there some discoloration that could happen in the timber or the surrounding materials? What do we have to think about? So we just give knowledge on those aspects.
Interesting. I want to ask you again the question, but maybe in a different way. What like some promising materials? I'm really interested in wood fiber. Yeah, I think it's got some great potential. Simon Corby in another episode, CEO of ASBP, said it's a great material and you can produce it so easily, very easily. There's hemp that is not so much in the UK, but there's a lot of countries that are really putting a lot of emphasis on hemp. I'm gonna have Paul from Eco Cocoon, who produces, I don't know if you know the company, but they produce modular
Yeah, I know them very well.
elements with straw, and they don't produce straw to produce the panels, but it's a bioproduct. So, there's loads of other materials like cellulose that is really good for sound absorption. How about cork? It's got some resistance problems, I understand. How about recycled rubber, which is marketed, and there's no offense because I really like the materials, but it's marketed as a sustainable material because obviously recycles the rubber, but is it and it can be reused as well, repurposed and recycled again. What's your opinion on all these materials? Maybe if we probably wanted the full list.
I mean, what you just mentioned with sustainability, that's of course always a very difficult definition. There's also always a risk of greenwashing. I mean, it's easy to claim you're sustainable, but so I think a lot of these materials together are actually the solution and are promising. I personally really love all the fibrous materials. As you mentioned, it can be hemp, but also timber fibers. I have 2 colleagues researching in that area, making a lot of new fiber insulation material, for example, which are really great. And you can also work a lot with the maybe not like the best grade of timber for those ones. You can use rest materials. You can use old timber or other materials for these fibrous materials. So I think that's really something promising. Working on that one, and then as I mentioned before, I think really recycling of material, also as a like structural material using timber and using that again. I think that's also really the other area that is the thing of the future. Looking more into that. A lot of people are talking about recycling timber, but feels like nobody's really doing it yet. I mean, we're looking into it, how to do it better.
Do you do EPDs as well? Do you produce any EPDs at all?
We do have other departments or sections within DTI that are working a lot with LCAs and EPDs. Yes, I'm not personally doing that, and I wouldn't know of any of my close colleagues and doing so either.
Let's get into timber elements, timber resistance. What exactly are you working on at the moment? And I've got quite a few questions about.
With timber elements, you said?
Yeah, resistance of timber. Well, let's get into it. So a lot of conversations in this podcast and privately as well. There's the fact that timber CLT is probably not is very expensive, and there may be some alternatives that could be used that are cheaper. What do you see as alternatives? Not wanting to make any competitions, or and what do you see any kind of, obviously without, you probably have NDAs, but what do you see coming up as other alternative elements that are very promising?
I mean, yeah, as you just mentioned, CLT, I think it's a great material, but sometimes it's maybe also used in places where it doesn't make much sense, just because people don't know there's other possibilities as well. What I personally think is that like maybe a CLT panel is most closely comparable to concrete. So that's maybe why structural engineers with less experience often chose to go with that one and calculate that one, because they can understand a bit better how this works. So what I think is that a lot of countries that are starting new with the modern timber construction, they look into CLT. It's somewhat easy to implement compared to other systems. And but then people don't know about all the other options. So if you look into countries that have been working with timber like traditionally or for more years, I mean, now I'm from Switzerland, so I know the market in Switzerland, but also Austria and Germany. You see there's so many different options to also build in timber that are more material efficient, for example. So I think as more developed the country gets in like timber construction, then like you have, of course, you need the industry, the manufacturers, but also the craftsmen that know how to build it, and of course the planners that know how to plan it, how to draw it, how to calculate the engineers. Then you go more into prefabricated elements, for example, so frame elements that are closed on both sides with boards that have the insulation included. Sometimes it comes completely with the gypsum on the inside already, with facade cladding on the outside, sometimes even with, for example, windows in. So you can have basically prefabricated walls completely, and instead of CLT, you use some kind of frame elements. For ceilings, you have not only like beam or like cassette elements, you can also have box elements that include acoustical sense or other things to have a more resource efficient or maybe a bit thinner solution. But quite often, of course, that has an implication on price and so on as well. So I think this is really something that we should look more into, because CLT might be very easy to use, but it's also using quite a lot of timber. And if you imagine a facade element, you cut a big window into it. What do you do with that piece where you cut the window out? So with frame elements, for example, you can design more efficiently on that regard. So I think that's one thing to look into. And then the other thing is the thing that is coming again is design for disassembly, recycling. So I mean, that's recycling really starts at the design of buildings now. They have to be designed so that you can take them apart again in the future. You have to make all the connections so that you can disassemble them. I mean, if you just glue everything together, you will have a really hard time disassembling that in the future. So if you want your building to be disassemblable in the future, you have to connect it as simple as possible, or with screws that you can remove, and so on. So I think that's the other big trend that is getting more and more important. I mean, I've also heard clients that are more interested about looking into connections that are able to be taken apart, testing new connection systems, for example. EU projects are also focusing a lot on that, of reusing complete building parts, basically, or like all the way down to smaller elements. So I think we're going that way.
Very interesting. How about moisture? Let's. I don't know very much about moisture, and I wanted to research more, but I'm not very happy about myself. Before that episode, can you briefly explain the main challenges and some solutions, maybe?
I mean, that's why I'm here, so I can explain to you. Moisture in timber is something we have to address. It sometimes gets neglected. Sometimes people are aware or even afraid. They heard about some other projects where it maybe went wrong. They hear something that timber and moisture don't go very well together, which is true. But I think if you do the right planning, then you can really avoid any bigger issues. You just have to be aware of it and plan it early. And that's why you really need a moisture strategy and proper moisture management with the proper collaboration with everybody involved. So what happens often or most often is that during the construction, for the first thing, a timber structure is exposed to the weather longer than it should. So usually when a CLT slab or something or a column, glue lamp column is out there in the rain, I mean, you have to set the structure up. You don't always have several weeks of beautiful weather. So it usually gets wet at some point, which is not a big issue. The issue is if that water stays on, let's say, that CLT slab for a long time, because then it really goes into the timber and then the problems usually start. So as long as the timber can dry out, like first of all, if the water can run off, for example, a column, nothing much will happen. If it just happens very few times, of course, we're not talking about having it outside for a year. And then if it also can dry out, if it's not wrapped in plastic or if you don't put gypsum already on while it's still wet, then it can dry out and it will be okay after a while. There it's important to take measurements, moisture measurements in the timber, not only on the surface, but also deeper in, to check if it's below 18% or ideally below 16% of moisture content, then you're on the safe side, then you know nothing should happen. If it's wet for a long time, so then you can have issues, meaning that you can get mold, you can get fungi, and they can potentially be destructive, of course, destroying your building. Or if it's just mold, it also just looks ugly. It can discolor your wood, that you probably don't want to happen. And to have that happen, you need elevated moisture content and also the correct temperature. So if it's a bit warmer, usually it goes faster. So then this can happen. And usually it can happen, as I said, during construction period, because one thing is you can build a complete temporary roof, like a tent over your construction site, but most construction sites don't choose to do that because it's expensive and sometimes not very, very practical. And then the more successful construction sites, they're really good at covering all the elements as soon as they're installed. They put like temporary covers over it and so on. The less successful sites, they have it open for a longer time. Maybe they don't close the roof very well. They have maybe delays on facades or something until they're delivered. And then the timber just stays open for months sometimes. And rain just keeps on coming and coming and coming until the structure is really wet. And then it also takes a long time to dry off. And you probably start to see the first mold growing on structures quite quickly, actually. And then the second issue is that we see is usually flat roofs or other details that are not very well designed. So it starts very early on in the design. If you choose something that is really not very good for water, so it can be some penetrations in the roof or the facade where rainwater basically can run into a wall or into the roof. I mean, flat roofs, they're just very critical to have them tight, and we see often that they're not completely tight or that they get untight over time because they get a bit brittle and so on. So a lot of flat roofs have problems, and if then a little bit of water goes through constantly, suddenly you have issues in the structural panels, and it can be very complicated to replace the timber in a building if it's a structural element. And it can also happen from installations in a building if you have some water pipes, for example, being untight and you have some leakage dripping over years, for example. untight facade, dripping over years. It doesn't happen from today to tomorrow usually, but then the consequences can also really be big. So what can you do? I don't want to just say, oh, like everything is bad. No, you can, of course, for the construction thing, you can really have good management, moisture management, a plan. What do you do? When do you measure? So really go around, measure the timber from time to time, see if it's still in acceptable levels. And then also have a plan. What do you do if you see, oh, some timber parts are getting too wet? What should we do? So do we cover it? Do we install heating and dehumidifiers, for example, to dry the building out or something? So that can be options. Also have somebody appointed that is responsible, because otherwise it's quite easy that nobody feels responsible for it. And one thing that we saw was very practical is sensor technology, like automatic moisture sensors that are installed in wall elements, for example, or roof elements that send alarms once they constantly measure the moisture in the timber, and they send an alarm once it gets too big. Then you also know exactly where it is, the issue, because if a roof leaks, it can drip at a completely different place than actually the leak is, if it just runs through the complete structure. And it can take years until you see something like dripping inside. But with these sensors, you usually detect it very early before it actually goes deeper. And then it's also easier to find where the issue is. We also had, with one of the EU projects, we were building a demonstrator building here at the DTI, 2-story office building and lab building. And we did not plan on that, but unfortunately we got heavy rain, and it ran into our building, a lot of water. So we got really to put all of this into practice as well. And we saw that these sensors really pointed us to all the areas that were getting too wet. So we didn't have to open all the walls, for example, but we knew which elements were too wet. We could open those and make sure to dry them out, or which floors were completely fine and some of the floors got some water in, and we could open them, and then they were actually drying out quite well, and now the building is completely fine. But yeah, that happened during the construction period, and we were really happy to have the sensors and all the technical equipment and so on. And we also knew who is responsible. So I think that would be my main tip. Make a proper strategy and reach out to people who know more about it if you're not sure, because we don't want more buildings that get moisture damage.
It's very interesting. Thank you. I didn't want to stop you because it was great.
Very passionate.
And I didn't, What, and I was kind of listing the questions, some naive ones, some more serious ones. And I'm trying to remember them. But first of all, there's one material that I really like, and I know it's used a lot in Germany, is gravel. And it's great because you can add a lot of weight to your construction, which is good for acoustics. Obviously, it's not just the weight; it's also the stiffness that you need to add. But from the UK, when we suggest it gets rejected quite easily because people don't know how to procure it and they don't know the technique. But obviously, in terms of moisture, how do you deal if you maybe I don't know, if you have to insert some gravel and put some acoustic layers or structural layers on top, like some screeds? How do you deal with that?
You described it very well. Usually, so the advantage of a concrete building is that the concrete is very heavy, so it adds mass, which is good for the impact sound, like when we walk around on a slab. As timber is a very light material, that can have advantages, but like in terms of footfall noise, it's not that great. So that's why we add something on top. Having some kind of weight. It can be a concrete screed, which is often used, but it has its downsides. I mean, CO2 wise, and also takes a while to dry. So you talk about those solutions with sand and gravel. There's like bonded chippings or some other like loose fill basically that is bonded or can even be completely loose. We used some kind of a more gypsum based granulate before as well. Basically everything that is heavy will do good for the sound insulation in a floor. And then you, of course, depending on how heavy the material is, you need to vary the thickness on those. And I personally prefer the loose or like the fillings that are not concrete based, because they're better for the environment, I would say, in general. And also they don't bring more moisture into the building, which can be an issue, as said. Bringing a lot of moisture onto the timber. It can also, if it doesn't bring mold or so, it still can just bring discoloration, especially if you want visible timber. You might suddenly see water running down somewhere, so you don't really want that, of course. So I think these dry solutions are really good, and I think there's also quite a lot of research or going on in this. It's not happening here in my lab, but I know there's a lot of new materials developed. But as I understand, the technical or like the acoustic measurements and calculations take quite some time to do. It's a very complex area. So I know that some engineers, when we tried to include some of these products in buildings, the engineers, they hadn't much experience with that. They didn't really know how to calculate it. They said maybe the codes wouldn't allow for it and so on. So that sometimes it's not so easy to include them in your project. But I would say that's also very country dependent on what regulations you have.
Really, it's also the way you standardized it. How do you make sure it's always the same weight? Well, for acoustics, obviously. How do you make sure it's always that fine? How do you make sure, that this is mainly for the density for acoustics? So that's the main questions we get asked is, and so you need to have a process and to have a supplier. I presume you need to, how do you remove the moisture from those products? Do you have to heat them up? How do you do that?
From those
And the gravels, you can't take some gravel from a quarry and put them straight away.
I don't know how they actually produce them. I know that some gypsum board manufacturers, they use some, I don't know if it's leftover materials or if they use virgin materials for that, but they make these kind of gypsum gravels. I don't know what exactly it is because it is way heavier than gypsum, it feels at least. And it comes packaged in these bags. So I assume it's a very standardized product to exactly make sure for what you say. I'm sure the gravel, I mean, you don't go out and just find something. So usually you would buy some kind of acoustic gravel or acoustic sand system. So somebody probably needs to guarantee for that as well, I assume. But I'm not an expert on this.
It's okay. How do you manage the moisture of timber bridges? I can see most of them are made of, obviously, when I Googled timber bridges and I could see a lot of glulam bridges, but there's a lot of other materials. How do you deal with that?
I mean, that's in general with exposed timber structures, we always have to be careful with putting timber outside in the weather, of course. What I personally think a great way is to protect it with constructive measures. So you can have some kind of cover or a cap It can be a metal cap on top, or it can be some kind of thinner wooden boards that can be replaced because they will degrade over time. But then you can replace them and basically protect the structural timber again, because replacing the structural timber might be very difficult to impossible if you think about the bridge or other structural elements. I mean, speaking of maybe a column outside of a timber building or something. So it's always good to think about how can we protect the timber outside. Then another way, if we think of thinner timber outside, more like cladding, then we can also think about more modification of timber, of impregnation. I mean, there's a lot of new ways to add chemicals or to add temperature or other methods to keep or to make timber more resistant. For bridges, that might not really apply. I mean, you can of course have some treated glulam as well, but you have to be careful as well with the delamination so that the glue doesn't reduce its strength over time, for example. So a lot happens outside. So I would say constructive protection is always the best. And make a smart design so that maybe the rain doesn't go directly on. Maybe you have a roof over the bridge, so the structural elements are a bit protected. For example, make your elements so that the water can run off and doesn't just stay on top of your beam, for example. And make the design so that the water doesn't run directly into your connections. So where you screw everything together, so make it a bit angled or something so that the water drips off as quickly as possible and doesn't go into the most vulnerable parts. I would say that's the best advice I could give to that.
And one very selfish question. I don't know in Denmark or Switzerland the structure of the houses mainly, but in the UK there's a lot of houses that are built in with bricks, and either they've got like solid bricks or they've got 2 layers of bricks and a cavity in between. And I've asked that question definitely to Simon and maybe to others on the podcast. But I've got a moisture expert here, so I need your view on it. A lot of companies will come and say you can put insulation in that cavity, and you can manage the moisture by having the right material. I've been told by a lot of architects that this cavity should stay as a cavity, like an empty cavity, because it needs to be able to breathe. Now, and I've also had a comment saying if you want to add insulation outside, so you can't fill the cavity, you need to leave it empty because the bricks need still to be able to breathe on inside. What's your view on everything?
I'm not the brick expert. That's my answer. But what I would say is that the experts that you were talking to, I think there is really something in it. So how we deal in timber construction is with it, definitely work with ventilated construction. So that would probably also apply to your outer brick layer. So if we talk about timber cladding, for example, it's always best to have it ventilated behind. So it's mounted with some air behind so it can dry out again, and it can get wet from both the weather but also the condensation. You talked about the added insulation as well, which can always be an issue. So with timber construction as well, we have to think about condensation. What happens if a warm material meets a cold environment? Then you get condensation, and of course you don't want that condensation just to stay. That's why we have the ventilation behind it. And in terms of timber, of course, that would be very destructive if the timber had condensation on for a very, very long time, because then it would always be moist and basically rot in no time. So probably the tips with keeping it ventilated was smart, but I'm not the brick expert.
Yeah, because I got told. Obviously, the bricks can breathe quite well, and then the external leaf of brick needs to be able to let water through or moisture through, which with an external insulation it won't be done as well. But yes. So have we gone through it? No, reusing and reclaiming materials. Can you briefly talk about what you're working on?
I mean, I've mentioned a little bit something, but the two EU projects, or especially the Wood Circles project, is a very important one on that, where we're working together with partners from different EU countries on how to prepare the industry to reuse, reclaim and reuse timber more. We're doing practical tests on that. So what we've done so far was we got timber back from different timber buildings from different areas with different ages, both glue laminated timber, but also just old construction timber. We were looking at what to do with it. And a very practical problem we met is like there is a lot of nails and screws in that timber. And of course, if you want to process that wood, you have to remove those, because no processing facility wants any metal to go through their saw blades. And that actually is not so easy first detecting or finding all the nails that are in there. There might be some broken off screws and so on. And then to remove them. So we have Stora Enso as a partner on that, and they found a way to somewhat detect them and kind of drill and pull those metal pieces out. And there we're looking at making new CLT panels from reclaimed timber. And
how is it going? Sorry.
So it's going well so far. So what we're doing, of course, in that scenario is taking old timber, cutting it up into new lamella, treating these lamella like if they were from virgin wood. So we can strength test them, for example, also in our labs, and see are they as expected, and then make new materials. I think it gets trickier once we take like a complete beam or even a complete frame or system and want to reuse it without cutting it apart and so on, because who will give you the guarantee that it is still strong enough? You don't know what happened to that system the last 20, 30, 40, 50 years, or even longer. You don't know if it has been in maybe some structural issues or some moisture issues that you maybe cannot see by eye. So we are trying to find some methods how to recertify these timbers, because we cannot always take just the timber and break it, because then we know how strong it is, but then we cannot use it anymore. So we have to find some better methods how to estimate how strong the timber is. We're working also with like surface or visual grading to look at the timber and seeing how strong it is from that. But it's not so easy to detect the history of a piece of timber from the surface without breaking it.
How do you recertify them? What are the avenues? If you presumably you can talk about it.
I mean, we're really trying to figure out the system currently, because it's not really. I mean, most building codes just speak about virgin materials only, so you can only use new materials to build a structural system. They're not allowing for reused materials out of this reason. So currently we're trying to find a system how to bring this into the building code, that we can use these materials. And of course we need to find a way how to recertify it or to prove that they're still strong enough. We don't know if that works through saying they should be calculated as 10% less strong, for example, or some extra safety factors, or if there's an easy test to validate if they're strong enough, or if we should just take some kind of a few samples from a demolition site and say how strong a few of these pieces are to calculate an average. So we're working on it. Yeah, it's quite complex.
You mentioned the demonstrator project from Building Wood. You're very active with Building Wood. But can you give more details about it?
Absolutely. So Building Wood has been an EU project as well the last 4 years. The project finished in 2024, but the demonstrator project, which was basically the result. I'm sorry. So the demonstrator building, which was the result of this Build in Wood project, is still under construction. It's, as I mentioned, a 2-story building. It is split. Half of it will be used as a office and the other half as an experimental, we call it lab part, because it is constructed so that we can replace basically all of the elements, or almost all, facade panels, floor panels, and so on, to put different materials, different systems in and test them. So the idea is that we can conduct acoustical testing in like a real life scenarios, or like practical setting. And there's a lot of moisture measurement already going on, as I mentioned, like during construction. And of course, they will also keep on once the building is finished. And there's a lot also heat flux sensors to be installed to measure like the difference of temperature, or like how long it takes from the inside to the outside, for example. So it's a very interesting and very complex project as well. So even though it's quite small, it has a lot of new solutions in it. So all the partners, of course, came with their knowledge. Building Wood was to further the timber industry in Europe, and there's a lot of new connection systems, for example, that have been developed. We're testing different foundation system as well. So there's a lot of research going on around that building, and it's we really could test a lot of system that you probably wouldn't be able to just implement in a commercial building, because no client would be like, oh yeah, this I want to be the first one to test this new system, as clients can be a bit more hesitant. But yeah, I would say those are the most important ones. It should be finished within the next few months. And what we have so far is mainly moisture data, which already is very, very interesting. We installed, I think, around 170 different moisture sensors all around the building to see how the moisture in the air affects the timber, how long does it take to get wet and to dry out, and also how long does it take maybe if during construction rain ends on the CLT panel, how long does it take until it's reaching the bottom of the CLT panel, and all of these different aspects.
Who are the partners? Can you name them? Well, they're on the website.
All of them. I would need to look at...
Okay, the main... so I can see... So obviously the architect is Wolf Hisselton. Right?
Exactly. Yeah. I didn't want to forget any of them.
Yeah, obviously.
So
apologies in advance.
No, exactly. So Wolf Hisselton Architects have been the architects. We are the coordinators. We also had universities involved. for example, Siena, University of Siena. We had Rotoblas for new connectors. We had,
Obviously.
yeah, exactly. We had Stora Enso and Knauf for the material side included, but also, a lot of others. I think in total there were 21 partners, and we had a really nice collaboration on that one. I think it's great when the industry works together. Also, sorry to all other partners which were not mentioned. Please look it up online. There's all the
If you've been forgotten
partners
and you
mentioned.
know you listen to that episode, just write it in the comments, and we'll update the show notes to add you as a member.
Exactly. So it's been a really nice collaboration within the industry, and I think also with the other EU projects that I'm working on. I think this is really a promising thing, seeing that we're trying to find solutions together and learning from each other, because it can be very easy to try to keep your knowledge safe and maybe not sharing it across borders either, even though there's so much to learn from each other.
What sort of acoustic test are you planning on doing? If you have a plan,
Mm, So
materials.
the acoustic test that is happening now at that stage was doing acoustical testing first on the floor slabs alone. So we have different kind of floor slabs. We have both CLT slabs and like floor cassette elements. We tested those ones, but we were first testing the like raw CLT slabs, measuring basically from the room on top to the bottom what the footfall sound insulation of just the CLT slab is. And then the next measurement was, as far as I know, once the build-up on that slab was with that acoustical fill or granulate on top or sand. And then also the final measurement will happen once the flooring and everything, the walls and so on, are installed. And the idea with it is to basically see early on the tendencies or where it's heading, maybe also figuring out which layers add how much of sound insulation, but also to basically be very early seeing if the acoustical insulation will be good enough, because I heard that's a very difficult part. Once of course the building is finished, it's difficult to change anything about it if you figure out then that the sound insulation is not good enough.
So you're saying the building will be finished in a few. It's not finished yet, but it will be finished soon. And it will be. And after that, it will be available to anybody to do some tests. I'm really interested to, if you've got that type of building, there's one project application I can see at the moment current project where we're looking at box construction. So what can we achieve with a box construction and the type of inner or outer construction? And yeah, what are the plans for after?
So for the lab side, the idea is that we exactly do things like you suggest, work together with partners. It can be both research projects or industrial partners that want something tested in the building. So everything is basically, we can take the complete floor elements out. We can test new facades and so on. So definitely, if you have some cool idea and suggestions, we can always add that to the building and make testing happen.
We'll be in touch after.
Yes.
Because I've actually got quite a few things to mention. Wood circles. You mentioned it briefly earlier. I can see there's a lot of partners. Can you briefly describe it, or maybe in detail? We'll see.
The project or the partners?
The wood circles, the project.
Wood circles is Exactly about the reuse of material, recycling of material. So where the Technological Institute mainly is involved is in both as the project coordinator, but also in the testing and recertification of the materials. So I mean, there's a lot of partners looking into different aspects of reusing and recycling timber, but we're in that work package as they're organized, the EU project. So we're working together with partners, getting timber from building sites, testing it just as raw as it comes, finding solutions how to maybe sort timber at the very initial stage into different classes, or looking, is there any fungi or anything present on the construction wood, demolition wood that comes to us. Then we've been sending it on to the manufacturer. They look into it, they process it. It will come back to us. We test the processed wood or the finished product, and then we will, together with also Wolf Thistleton Architect and other partners, develop basically a bigger system how to apply these reused materials in the real world. And we're trying to, of course, think of recertification and standardization ideas to make it possible in the future, to make this a bit easier, this process that is very complex.
I can note that on those projects, there's no big consultancy players, or maybe I'm wrong. And obviously, no offense to any of them, but is this true? And why is that? It seems to be, obviously, they're really good size organizations, but I don't want to mention the names of the big firms, but you know who I mean generally.
Yeah.
Why are they not too involved?
I am actually not completely sure. It's not on me to choose,
Yeah.
and they have been chosen also before I joined the project. I could only guess on that. All that I know is that with all those smaller companies that are now part of it, we have so many, like, we have a lot of specialist knowledge, maybe a bit less generalist knowledge, to really together make this project, to say it like that. So I don't know, maybe it's contractual things. I cannot answer.
How, and finally, Timber House. Again, can you describe a bit more?
Yeah. So that's the newest EU project that we're working on. We're at DTI again, project coordinator, and I'm very happy to also be part of this project, looking into the using more of the underutilized timber or forest products. So as we're still at the very early stage, we're still drafting exact ways where to go, but we're working together with very interesting other partners that have been working on for example, using more of a tree once it's cut down. How can you actually use more of this tree for construction timber than that they're doing currently? Because of course, you cut down a tree and a lot of it is side pieces and branches and even down to the needles, which a lot of it is used for energy, meaning burning down, or maybe some of it for particle boards. But how can we use more of this? Or how can we use different species? Because that's still a thing. We're using a lot of spruce, a lot of pine for construction wood. And how can we make it easier to use different kind of species? It's not as easy as you think, because you have to certify basically different species as well. And if you go further into especially hardwoods, you have completely different challenges there as well, with the gluing of these ones and so on, even though they're way stronger. And then sometimes If you, for example, look at oak is a very, very beautiful timber, but it's also used for a lot of different applications. So maybe it doesn't make sense to use it for constructions when it's so
It's very expensive.
Exactly. It's so popular for other applications. So that's why we probably don't use it too much. But there's so many different species in our forests that we could use, and different smaller trees or rest products. So currently we're finding ways how to, or looking at which aspects we should use, what could be relevant. We're working with different countries. So these different countries might have different challenges. So in some countries, maybe they have like very, a lot of different species that we could look into and how to use them. And I think that will be a very interesting task for us at DTI as well, to test a lot of products, to consult with the other partners, how to also make a real life case out of it. Something like the build-in wood demonstrator building, for example. I hope that we get some real result out of it as well in the end of these products, proving that it's really possible. Our crazy ideas that we're having currently. That's how much I think I can say for now. But it's definitely going to be a very interesting next 4 years.
Yeah, it sounded like it. Well, thank you very much, Fabia. It's been very nice, an hour and a half. Crazy.
Thanks. Thank you for having me.
I've had an episode, it was not for this series on sustainability, but some episodes were about 2 hours. But this is probably the longest on sustainability. But it was really, really interesting. How do we...
About timber.
Yeah. Could talk for hours. How do we get in touch with you or the DTI if people want to reach out to you, contact you?
If people want to reach out to me, which of course I hope very much so, because I'm sure you guys have great ideas as well for us where we could collaborate, then you can find us either online at the Danish Technological Institute. You find it online, or you find me, Fabia Baumann, via LinkedIn. And I think then we should be able to get in touch.
Yeah, great. It's been very nice speaking to you and listening to you.
Thank you so much for having me.
No problem. Bye, Fabia.
Have a good weekend. Thank you so much.